What up, YouTubers? This is a continuation of the previous video I posted on this SAT math subject matter. This is fundamentals practice, so if you struggle with your square roots, perfect roots, integers, rational numbers, exponents, this is a perfect section for you to practice and a perfect lesson for you to watch, because this chapter goes over lots of fundamentals that we may have forgotten and that will pop up on the ACT and that may confuse us. Also, I'm going to go through, when I go through these problems, I'm going to highlight several buzzwords that the ACT likes to use that don't necessarily confuse people, but that people tend to overlook. So that's going to be an important part of mastering this type of test. So let's get started. Number 18, which we left off on. If R and S are non-zero numbers, our first buzzword, non-zero numbers. Whenever you see any phrase that may point to stipulations towards the answer choice we'll have to prove, it's always nice to circle them, such as there. If R and S are non-zero numbers, when is R over S equal to S over R true? This type of question, I remember, personally would usually always be a long one for me to answer, because I would try to delineate too perfectly which numbers to go from. I would never look for the simple routes. I would avoid tricks mainly. Not necessarily avoid tricks, but I would always use tricks as a last resort, but that was always the wrong way of doing it. I'm going to show y'all the right way to do it, because I've learned the right way after so much failure. So, non-zero numbers is our only stipulation. So that means we have from whole numbers to rational numbers to choose from, positive to negative numbers to choose from. So the two numbers we want to choose have to fit the stipulation. If R over S equals S over R, yeah, it has to fit that stipulation. R over S equals S over R. So, off the bat, if I get to choose a non-zero number that do not have to necessarily be different, I'm going with 1 over 1, because 1 over 1 equals 1 over 1 regardless of whether I plug in 1 for S or R. So S equals 1, R equals 1. So that's the first part of answering this type of question. The second part is looking through the answer choices and figuring out which ones apply mostly to this question. Which one is the most correct? That is the answer you want to look for. Not most correct, but the absolute correct. So, F always, if R and S are non-zero numbers, then R over S equals, that is not always true. Because if for S and R I would go with 4 and 1, I would end up getting 4 over 1 equals 1 over 4. Which would be 4 equals 0.25, which is false, so that is an incorrect answer. Only when R equals S. Let's think about that. Because the two numbers I chose, 1 and 1, fit the stipulation R equals S. However, it does not necessarily always have to be like this. If I were to plug in 1 for R, but negative 1 for S, I would get 1 over 1 equals negative 1 over 1, which we know would be the same answer, and is not. And in this answer choice, R does not equal S, so you cannot say this is always true. You cannot say only when this is a stipulation. And H, only when R equals negative S. It's just like G, except we're working with this as your template, and now this is your rebuttal. Because only when R equals negative S, 1 over negative 1 works, because negative properties and the properties of 1, whenever you divide negative 1 by 1 or 1 by negative 1, you're going to get negative 1. However, we go back to this, our rebuttal, 1 and 1 are, R is not in this instance the negative S. So only when R equals negative S is not true, because 1 over 1 equals 1 over 1. The phrase is contradictory. So, only when R equals plus or minus S. This answer choice is the best of G and H, and I will show you why. only when r equals plus or minus s. What this means is that if r were to be 4, in order to equal plus or minus s, you would either get this or that. That is what that means. And with this, you don't go wrong, because if you go with -4, you get -4 over 4, which would be true because 4 over -4 equals -4 over 4. And if you were to go with 4, you get 4 over 4 equals 4 over 4. So J is your correct answer choice. This one took a while to work through, but it's one of those that can get somebody who overthinks the question, or once again overlooks to see the non-zero factor. A lot of people would have just gone with G because it fit the two numbers they chose. However, as the scholars that I know a lot of y'all will see through this ACT, y'all notice these ACT buzzwords, and y'all will get the correct answer. So, next question. What is the greatest integer that is less than root 77? This is a fairly straightforward question. No tricks to this one. The greatest integer, we're going to choose buzzword greatest integer. Less than root 77. So if I get, well, let me first calculate root 77. Root 77, that is about 8.774. So root 77 equals 8.774. What is the greatest integer that is less than root 77? So off the bat, 9 and 10 are wrong. Also, another buzzword I forgot to underline, integer. If something is an integer, it has to be a whole number, which means C cannot be the correct answer because it's a rational number. It's decimal, it's not whole. Now, the closest number to 8.774 that's left out of 8 and 7 would have to be 8, because the 8 is the closest number to 8.774. 7 is too far. This is fairly simple. This is how, it was also very straightforward, which separates the ACT from the SAT. So you will get a lot of questions like this. Don't overcomplicate these. They're pretty simple. Just know your fundamentals, and you should be very well off. Number 22. What is the largest possible product for two odd integers whose sum is 30? More and more buzzwords. Let's go. The largest possible product for two odd integers. Two odd integers is pretty important. You can't choose an even number that has to equal to 30, and this has to be the largest possible product. Off the bat, many of y'all may already know the answer. Many people who know the perfect squares may look at this and may look at K and automatically see the correct answer, because K, two odd integers whose sum is 30. The square root of K, the square root of 225 is 15, because 15 times 15 equals 225. So that's a fairly easy question if you remember your perfect squares. If you don't remember your perfect squares, it's going to take you a while to plug in the different combinations necessary for every single one of these answer choices, which will be time eating, which will not be good for you, because for the ACT you have 60 questions in 55 minutes and you need as much time as you can get. So knowing your perfect squares is big for this question. It's also going to be big for many other questions on the test. Next question, number 24. What is the value of 3i4 minus I negative 2? This may look confusing for somebody who's maybe forgotten about what the value I might mean, somebody who doesn't do well with these type of non-numerical expressions, but that's what I'm here for. This was simple. As long as you break it down, as long as you don't panic, this can be a very simple question to answer. So what is the value of 3i fourths minus I to the negative 2? Note I squared equals negative 1. You might see the note here and assume that this is only a condition for this question in specific, but always know that I squared equals negative 1. Negative 1 squared is going to equal negative 1. That's why that's there. That's not a condition just for this question. That is going to be a condition for every. It's a law in math. You should always know it. Now let's break this down. I squared equals negative 1. And let's rewrite this as we go down. 3i squared, which can be broken down to 3i squared minus I squared minus I to the negative squared. So 3 times I squared minus I to the negative squared. If I squared equals negative 1, we can already substitute negative 1 for I squared. So 3 times I squared is going to be 3 times negative 1 times I squared times another negative 1 minus I negative squared. 3 times negative 1 times negative 1. Oops, my computer seems to be running low on battery. Negative 1. So that's going to be negative 3 times negative 1. So 3 minus I squared minus I squared. So a lot of y'all may look at that and be confused, but what I minus squared? What I negative squared is the reciprocal of I squared, which is just going to be negative 1 again. Because if you take the reciprocal of I squared, which is negative 1, you get 1 over negative 1, which is negative 1. So in total, this expression amounts to 3 minus negative 1. And just do that little trick because the negative minus the negative. But it's subtracting the negative makes a positive. 3 plus 1, your answer choice is going to be F.